Okay, Stats Kids, this is the start of chapter 2. We're in 2-1. I'm going to separate this into two sections. So today we'll do the first half of 2-1, probably till we get to like right after categorical data. So probably about right here is where we'll stop for this video. And then tomorrow I'll do the second half of it, so the bottom. So they are talking about, so last chapter we talked about how to collect data, how to sample people to get data from, all that good stuff, like all the background information. And now it's like, how do you start doing computations with that data or organize the data, right? So creating frequency distributions is one of the main ways of organizing lots and lots of data to put them all into kind of one big summary. So summarizing, organizing data into something called a frequency distribution. You've probably seen one of these before, but here we go. So a frequency distribution or a frequency table has classes and then gives a frequency, which is or a number of elements within that class. Okay, so it has classes, and then it has the number of elements or a number of people or the number of whatever that are in that class. So if we kind of dissect this table, we have the age of Best Actress when the Oscar was won. So like Academy Awards, how old was the actress when she won the Academy Award or when she won the Oscar, okay? So we have 20 to 29-year-old women. There were 29 people who were ages 20 to 29 years old. There was 34 women who were the ages 30 to 39. And then there was 14 that were within the ages from 40 to 49, 3 that were 50 to 59, and then we kind of dwindle down. So we do bump up to 5 that are 60 to 69, and then only 1 that's 70 to 79, and 1 that's 80 to 89. Okay, maybe like Betty White or somebody like that, okay, that are in some of those upper categories. And kind of one of the things that we can see with this trend, at least, is that the majority of our data values are going to be like in this lower range, okay? So that's kind of one thing that we look for with the frequency tables to like identify trends. And this kind of makes sense that we're talking about ages of Best Actresses, which is like ages of women. And sorry, women, we don't age very well. Like we get the wrinkles early and the gray hair and everything. Guys, you have no stress in your life, so you have like no gray hairs at all until you're like 50 pretty well. So women are going to be more successful in acting careers probably when they're in these younger ages, right? Versus then they turn old and then they have like very few of them that are winning Best Actress, okay? That's the trend that this table is showing us, okay? So that's why a frequency table is good to have, because we can kind of break down that data, okay? One downfall of a frequency table, okay? I'm going to show you this because we talk about this a ton. So put a big star. The downfall is that you lose, L-O-S-E, there we go, lose the value of each data number, okay? So what I know is that there's 29 numbers that are in this range, okay? Maybe all 29 of those women who won in that age category are exactly 24 years old, okay? But we don't know how old they are. I only know that there was that many people in the range from 20 to 29, okay? Maybe 2 of them were 20, 4 of them were 21, 5 of them were 22, etc., right? We don't know what the exact numbers are. So when we crunch them down and we put them in this table, I lose the actual value of each data. I only know that there's 29 numbers in that range, okay? So I hope that makes sense. We kind of lose the integrity of the values themselves, okay, by putting them into a range or a frequency table, okay? So that's the one major downfall. All right, now, they're going to have us, and they're going to talk about some terminology of this frequency table before we move on and actually construct a frequency table. So we have stuff called our lower class limits, okay? So if this is a class right here, the lower limits would be the lower number of each class, Okay, so for example, we have 20 is the lower class limit, 30 is a lower class limit, 40, 50, 60, 70, 80, right? Those are all my lower class limits because they're the bottom number of each class. Okay, that's pretty easy to figure out. Upper class limit is going to be the upper number of each class. Okay, all right, so if the lower ones were the 20, blah, 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 all the way through, these are going to be my upper numbers, 29, 39, 49, 59, etc., right? I'm going to list those out, 29, 39, 49, 59, 69, 79, and 89. Those are my numbers, okay? All right, class boundaries. Out of all of these, class boundaries is probably one of the hardest to identify, okay? So here's the deal. Suppose, okay, so 29 and 30. The ages between 29 and 30, like 29 and 30 is where my cutoff is for the two different classes, right? So if you're 29, you go in the one category. If you're 30, you go in the other category, okay? But every once in a while, we have like decimal numbers. So like, let's say we're talking about, times in a race or whatever, and this was 20 seconds to 29 seconds. What if I was 29.2 seconds? Okay, 29.2, you would still go into the 20 to 29 category versus, like, let's say I was 29.8. Then I would round up to the 30 category, okay? So what is the class boundary? Okay, the class boundary is going to be the place that, that's halfway through that tells me whether I round down to this category or I round up to this category. And it's exactly in between 29 and 30. Okay, so it's 29 and a half. Okay, so 29 and a half is going to tell me where I round to. I hope that makes sense, okay? So 29 and a half is going to be my first class boundary, okay? Then the next one is right in between these two numbers, 39 to 40. 39 and 40 are my cutoff marks for the two classes that are next, right? So if it's lower than 39 and a half, like 39.3, it's going to round to this. If it's 39.6, let's say, it's going to round up to 40, okay? So 39.5 is going to be your next class boundary, okay? 40.9 would, or 49.5 is going to be your next boundary because that's exactly in between 49 and 50. Then you have 59.5. Then you have 69.5 and 79.5 and 89.5. Now, one more thing. I know that when you guys fill out your homework assignment on this section, they're going to trick you on this because there is technically one class boundary that is in front of 29.5, and that is what separates that and makes that 20. So that would be like 19.5 because there's like a class boundary ahead of that class, ahead of the 20 to 29 class, okay? So don't forget that 19.5 also goes in there as a class boundary, okay? So your class boundary is going to be halfway between, I'm going to say upper and lower. Okay, I hope that made sense. If that's not a very good definition, come up with your own definition. But the upper of the one right before it to the lower of the one after that, you find that halfway between, and that's where your cutoff marks. And it basically just tells you how you round. So do you round down to the one class or do you round up to the next class? And that's kind of how that works. Okay, so that's the confusing one. Boundaries is the hard part. Okay, now class midpoints is just the midpoint of each class. So what is exactly in the middle of 20 to 29? Now, what you can do is, if you're trying to find the midpoint is like finding the average. So midpoint equals average. So what you can do is you can just take 20 plus 29 and divide by 2. And that will give you the halfway point. If you want to do that, you can. If you can't figure it out, or you can just do it in your head, halfway between 20 and 29 is 24.5. That's your first class boundary. It's just right in the middle of 20 and 29. Right in the middle of 30 and 39 is going to be 34.5, then 44.5, then 54.5, then 64.5. This gets a little tedious. then 74.5, and then 84.5. Those are my class midpoints. That's the middle of each class, okay? Again, if you want to do the average, you can, but that's what you'll get is those guys there, okay? Class midpoint is the middle of each class. I don't know how I can like be any more clear than that. I don't know. Okay. Now I'm going to put a star by class width because kind of like class boundary, it's a little bit easier to do, but a lot of people screw up class width. So put a star by that because if I say how wide is the class, guaranteed the majority of you guys are going to say 9 because 20 to 29 is 9 units. But your class width goes from, are you listening? Goes from this guy to this guy, like the start of one class to the start of the next class, right? Or you can go from the end of one class to the end of the next class, okay? It's like exactly the same distance apart, right? So from 20 to 30, your class width is actually 10 units, okay? And class width is the only one that you're only going to have one answer on, right? Like you don't have to list out all of them because every single class has the same width, okay? So it's going from either upper to upper, which is these guys, the 29 to 39, or lower to lower, which is 20 to 30, okay? It is not going from this guy to this guy. That's not how wide your class is. But if I ask you how wide your class is, the majority of you guys are going to say 9 units, okay? It's not 9, it's actually 10 units, okay? So I'm going to say for this one, the distance from lower to lower or upper to upper, okay? So that's something that you do not want to mess up. Upper to upper, okay? All right. Okay, so now that we've got all the terminology, we've got all that stuff, now we want to actually construct a frequency distribution. So let's talk about how they do this, okay? So like, how do they determine like what numbers to use where? Like after we have these classes established, all we have to do is go through our data and like tally them up and get these numbers here. But how do they determine like 20 to 29, 30 to 39? Here's how they decide. So we usually try for between 5 and 20 classes. So this one has 1, 2, 3, 4, 5, 6, 7 classes. That's pretty standard. If you have like lots of data points that are really spread out, you're going to do like lots more. So maybe even 20 data or 20 classes, okay? But somewhere between 5 and 20, no less than 5, okay? 5 and 20, this one had 7. And you're going to decide how many classes do you want between 5 and 20. And then you're going to calculate the class width. So like how wide each class is. So here the class width was 10 from one to the other, okay? And to do that, you take your highest data value, whatever your biggest number was, you subtract whatever your lowest number was, and then divide by the number of classes you want, right? So if your largest number is 100 and your smallest number is 20, and you know that you want 6 classes, 100 minus 20 is 80, and 80 divided by 6, whatever that is, and that's how wide your classes are going to be. Okay, now we have some problems. If you end up with this number being a decimal, you're always going to want to round up. Because if you don't round up, then you will end up going from like 80 to 89, and your last number will end up being like 92, right? You will not catch that last data value if you don't round up, okay? And if you round down. So we'll see that here in a second, like how that works, okay? So number 3, after we've established the class width, however wide it's going to be, we're going to actually do this down here. Choose the value for the first lower class limit by using either the minimum value or a convenient value below the minimum, okay? So what they did here is maybe my lowest number was actually 22 and not 20, right? But a convenient number, if I'm going to use a class width of 10, would be to start on 20 and go from 20 to 30 to 40 to 50, right? Instead of starting at 22 and going to 32 and 42 and 52. That's just confusing a little bit. So 20 to 30 to 40 to 50, that makes it kind of nice numbers, okay? So you can choose a convenient, circle that word. Where is he at? Choosing a convenient value a lot of times is what they'll have you do, okay? All right, using the first lower class limit and the class width, list the other lower class limits, and then you build your classes from there. So let's do that here, okay? We're going to actually do this, and I gave you the time and the frequency, and we're going to fill this table in. Okay, so let's look at what we have going on here. Drive-through service times for McDonald's lunches. Okay, and these are all in seconds. So like I went through the McDonald's drive-through and it took me 107 seconds before I got my food. Okay, that's a little less than 2 minutes, right? Like a minute and 45 seconds. I don't know, something like that, right? Close to that, okay? So some of these took, like this one took 91 seconds. Like that's really, really fast. This one took 90 seconds. Really, really, really fast. Versus some of them are like way bigger than that, like 308 I found up here, right? That's taking up to 5 minutes to get my food. Which I guess if you're sitting in a McDonald's line to, get your food, like in a drive-through, that might seem like a really long time, okay? So we need to make our frequency distribution, okay? And I went ahead and left this table here because there's 1, 2, 3, 4, 5 sections to it, which means that we need 5 classes, okay? That was just kind of our hint. They will tell you how many classes use 5 classes right here. So we have 5 classes. And then we need to decide how big our classes are going to be. So we need to find the maximum value and we need to find the minimum value on this table, okay? All right, so our largest value is it 308? I'm going to look. I'm going to circle 308 and I'm going to look and see. 308, 308, 308. I think that it is. 308. I think that's our largest data value. Okay, then our minimum, our smallest data value, like I see 83 right here. And there was a 90 and a 91, but I think 83 is the smallest. We're going to go with that, okay? 83. So we know that we want 5 classes, and we basically take the range. So we take the largest number minus the smallest number, and we divide by 5 classes to figure out how big that is, okay? So 308 minus 83, let me get my calculator out. 308 minus 83 is 225. And if I divide that by 5, I end up with 45. Okay, so our class width has to be 45 units long, okay? Now, what I'm going to do is I'm going to round this up a little bit to a nicer number. And rather than doing 45, we're going to round up to like 50, right? I wouldn't round up any more than like 5 data points, but if we can round it up to be really nice, that's a kind of a key there, okay? So if we go by 50s, that's going to make it a little bit easier on our classes because going by 50s is like really nice numbers, okay? And then our minimum number is 83, okay? So we could go like 80 to something and then start at 130 because that would be 50 units, okay? But let's do something different. Let's start at 75 because those are like increments of 25s, right? So if we start at 75 and go to something, then 50 units for a class would be 125, right? 125 to something. And then if we add 50 more, that would be 175 to something, and then if we add 50 more, that would be 225 to something, and then if we add that many more, we would go to 75. Whoop, let me erase so I can write that better. 275 to something, and then I'm going to go one more, but I'm going to put this in a different color because we're going to erase it. If we add 50 more, that would be 325, right? Okay, so keep that in mind. We want that last value. We're going to erase that though, okay? So if we're going 75 to something and our next class is starting at 125, this class is going to end at 124, the term right before that, right? Okay, so each one of these is going to be just one term right before that. 125 to 174, 175 to 224, 225 to 274, and then 275. The reason why I wrote this one down here was so that I could see that that's going to go to 324, but I'm going to cross them off because we don't need to do an additional class, right? 308 was my last one, and it does fit into this category, okay? And then we do frequency, which means we take each one of these and we tally up how many there are, and it's a really tedious thing and blah, blah, blah. We figure out how many there are in each one. Okay, so I saw that, I don't know, there was like an 83, there was a 91, there was a 90, all that good stuff, and then we can tally and figure out how many are in each one. But I'm going to cheat. and they use the same numbers as we did right here. Okay, so they went 75 to 124, 125 to 174. Holy cow, look at that. And they have it tallied for us. They have a frequency of 11, 24, 10, 3, and 2. So let's copy those on the front side. 11, 24, 10, 3, and 2. So that means that there are 11 of these numbers that fit in that range, 24 of these numbers that fit in the second range, etc., right? And we can do that by tallying them and taking like 3 years to do it, which you'll have to do some of those on your homework assignment. Sorry, don't kill me, but there is that, okay? So those are the frequencies, how many were in each one. Now, in addition to this, the reason why we do this frequency table is so that I can see what the trends are. So the majority of the time it took 125, which is about 2 minutes, right, to 174, which is a little bit less than 3 minutes. So it's taking about 2 to 3-ish minutes to get my food through the drive-thru, the majority of the time, because that's 24 in there. Very rarely do I end up in this top category where it takes me that long, okay? So we can see those trends from that frequency table of how this data plays out, okay? Now again, let's go through the downfall. The downfall is if I throw this table away and only use this thing now I have no idea what each one of these data values is individually. Like I lose the integrity of that data value or that table, right? By just putting them into frequencies, okay? So that's the downfall of that frequency table, but I can see trends when I go through this, okay? All right. I've talked a lot. I'm sorry. Let's go through one more example where we're talking about categorical data, because you can put categories into a frequency table as well. And so what they have is they say the data for the highest 7 sources of injuries resulting in the ER, okay? So they say bicycling is one of the reasons why you go to the ER. Football is another reason why you go to the ER. Playground, some people get hurt on the playground. Playing basketball, soccer, baseball, and then ATVs, accidents, which I think those would be higher, but maybe there's less people riding ATVs than there are people, like, let's say, playing basketball, whatever. So probably more accidents in basketball then. And if that's the case, ATVs seem like a more dangerous thing to me, but there's probably less people actually doing that. So, and they have these listed in order. They say bicycling is the most frequent one. Football is the next most frequent one, etc. Right? So the frequencies of how many ER visits that resulted from those 7 things are as follows. And this is all categorical data. Yes, these are numbers here, but we have categories that are kind of our classes. So these are our classes, and our classes are not ranges of numbers like they were here. They are categories, okay? So you can do that for categorical data as well, okay? So there's that. And we can, again, we do this so that we can see trends of things, all right? So I'm going to stop the video there, and then I'll continue tomorrow doing the bottom half, so starting with relative frequencies. So I would start your homework assignment. You've probably got some time left in class to do that. Please start it now, because this is kind of a longer section. Like, it takes a while to do this homework because you're having to do the classes and things like that, okay? So there's that. Start your homework. Do it now. If you come across a question that has relative frequency distribution or cumulative frequency distribution, just skip over that and then go back to it tomorrow, okay? You can skip questions and then go back after we talk about them, okay? All right, but that's all for today.